Yeah. Greetings, everyone. My name is Chintan Singh, and I'm a full-time PhD research scholar at Amity Institute of Forensic Sciences in Amity University, and I'm basically from Noida. So this work, which is I'm gonna present today, is for the 6th International Conference on Computer Science Engineering Education Applications, which was about to be gonna happen in Warsaw, Poland. So the research title of my work is the implementing a blockchain-based forensic model for integrating it on the IoT devices, so we can tackle the so many problems that are associated with the digital forensic investigation. If we'll talk about more on the overview part of my work, as we can know that the rapid advancement of Internet of Things and technology has brought many new challenges in the field of digital forensics. There are traditional methods also which are often inadequate in dealing with the decentralized and the distributed nature of IoT devices. So IoT has the several advantages. As we know, we all are connected to the IoT Internet of Things, and till now we have more than 30 billion of devices which are attached with the IoTs. So the technology and the resources available to today's cyber criminals allowed them to launch millions of sophisticated attacks which are also and again connecting with the IoT devices. So in this paper, we are just proposing our blockchain-based forensic model to tackle and to investigate such IoT devices whose authenticity and reliability can be questioned in the court of law. The proposed BBMFI, which is the shortened form of the blockchain-based forensic model, can be utilized for the immutability and the tamper-proof feature of the blockchain technology, which further providing a secure and reliable way for collecting, storing, and analyzing the forensic evidences from IoT devices. So one of the most important benefit of this particular model is that in digital forensic investigation, with an immutable chain of evidences that can be used to trace the source of data and its subsequent changes. For instance, when we are using this particular model, the forensic investigator can easily trace the chain of events that are associated with the particular IoT devices, and we are also implementing a blockchain network into them. So if any alteration or hindrance will occur between the network, so any particular forensic investigator will be know about that. So our result basically show the proposed network can provide a secure and efficient and also a tamper-proof solution for the various IoT devices which can be come in the digital forensic investigation. So let's move towards further in our slide. So I'm gonna cover about what are the overview of IoT devices, little history about IoT, how it all started, the first scientists who coined this particular term, the various problems which are associated with the IoT devices, what is digital forensics, and what part of blockchain digital forensic science is using, what is the aim of our research and our proposed BBMFI, that is the blockchain-based forensic model for the Internet of Things. Also, the potential and conclusion, what is the scope of this study and how and where we can use this particular model in digital forensic investigation. So if we'll talk about the Internet of Things or IoT, it is basically a system which is interconnected between the nodes on a particular network, and they have the ability to share the data over the network or transfer the data without taking any human intervention or any human to computer interaction. So IoT is a system of interrelated computer devices, mechanical and digital machines, object, animals, or people that are provided with the unique identifiers, which is unique for each and every nodes, and they have the ability to transfer this particular data over a network without requiring any human to human or human to computer interaction. So in today's world, IoT is driven the world. Many of the peoples who are connected in their day-to-day life for sure with at least 10 to 15 IoT devices. So these IoT devices now starting from 2012 when they are basically for I guess 10 to 11 millions. Now they are coming till the greater number of 30 billion. Now in worldwide we have more than 30 billion IoT devices. So Internet of Things, it basically comes in history by the concept as a concept which is driven by the Kevin Ashton in 1999. So Kevin Ashton, who is the MIT's executive director of Auto ID Labs, coined the phrase that is the Internet of Things, and he was the first to describe the IoT. while making a presentation for the Procter & Gamble, the definition of the IoT has evolved many over the time, but the basic definition that Mr. Ashton was stated by 1999, that the today's computer and therefore the internet are almost wholly dependent on human being for information. Nearly all of the roughly 50 petabyte of data available on the internet were captured and created by human beings by typing, pressing, or recorded button, taking a digital picture of scannings and the barcode. So the problem is that the people have limited time, attention, and accuracy, all of which means they are not very good at capturing the data about the things in the real world. And if we had computers that knew everything, they was to know about the things using data they gathered without any help from us. So we would be able to track and count everything and greatly reduce waste, loss, and cost. So this was the basically idea which was developed by the Mr. Ashton back in 1999. So started by that particular history, he also coined a term that is the RFID, which is basically stands for the radio frequency identification, which is a prerequisite for the Internet of Things and primarily act as an inventory for tracking the solution. Now, if we'll talk about again for the current scenarios, the smart cities also using the IoT devices to reduce the waste and maximize the efficiency of the energy. So they basically can also be used to streamline the traffic flows also in smart cities. We are developing towards the industry, 4.0, 5.0. We are moving towards 4G to 5G and 6G. And this all well-designed smart city can support all kind of sensors that are connected to internet and they can provide us the traffic monitoring, air quality monitoring, smart transportation, parking, public lighting, buildings, and so many other things. And in industries also, as an extension of IoT, they uses the actuator in smart sensors, which are networked together with the company industrial application. And they are supporting industry in this way to move towards the industry 4.0. So now the Internet of Things becomes basically a part of our life. And by the year of 2022, the IoT had become system, multiple technology ranging from the wireless communication and from micro electromechanical systems to the embedded systems. So this includes almost anything you can think of, ranging from mobile phones to building maintenance to jet engines of an airplane, medical devices such as heart monitor, implant of biochip, transport in a farm animal, and they can transfer any data over network. And by this only, by getting that much advantages of IoT, criminals also nowadays are using this particular Internet of Things to performing the crime. And this is the part where the digital forensic came. So there are basically some challenges that are associated with the IoT. That is, first of all, the device authentication, whether the particular device which is using IoT as a service is authentic or not, the data privacy, how much secure is our data ownership. We don't know actually who is the real owner of our data, because we are sharing our data over a cloud network through the various and millions of IoT devices. There is a problem associated with the supply chain security, firmware updates. We have various device complexities. We have the interoperability, and also by all these things, we have the trust issues also. So because of these many challenges, there needs to be a particular solution to get or conquer this particular thing, so that particular device can be used in the court of law and digital forensics. So let me brief you about what is the digital forensics. Okay, so digital forensics is the process of identifying and the preserving, analyzing, and presenting the digital evidences manner that is legally admissible. So we are just collecting the evidences from the digital. They can be from the system, they can be from the network, they can be from the mobile devices, or they can be from any cloud-based services, or they can be from the servers. So in digital forensics, we are basically collecting, preserving, and then analyzing and interpreting the data, so we can get the result from it. So we can track who's the particular criminal, who's the particular offender, and finally we will use it as the legal admissible evidence in the court of law. So in the court of law, when we are using any digital devices, he have to be authentic. There should not be any temperament into them. It should be authentic, it should be reliable. The judge and the people have to be believe that this particular data is legit and no one ever alter this particular data. So if we'll talk about the crimes which came in digital forensics, there are numerous and sophisticated technologies which people are using. It can be starting with tracking your phone, tracking your IP address, getting into your devices and mobile numbers by using the social engineering tools, tracking and gathering your the security data from a particular individual. So there are, I guess, in India, if I'll talk about, there are millions of cases which are coming in a particular year, and we have only very little part of that particular digital forensic investigation, which is utilizing a proper chain of custody, which ensures that this particular investigation and the devices associated in this particular investigation were not tampered and they are admissible in court of law. Okay, because the main problem we are facing in the digital forensic investigation is of the authenticity and the complexity of devices. How a judge can believe that particular device is legit and no one ever played or no one ever altered the particular device data, or any other criminal also can, in so many cases, other criminal also can come and hack our the digital forensic investigation system and capture the data. So to prevent these all things, we are developing BBMFI, that is the blockchain based model. But before that, I guess we have a little overview of what is digital forensics. So it can help in identifying the source of attacks or breaches in IoT devices, and also can help in determining whether the device is authentic or not. By analyzing the firmware of IoT devices, the digital forensics expert also can detect, as I said, any kind of malicious code that have been injected into a particular network. Let's say about the worm attacks in early history. If we talk about the first virus, that is the developed over the to share the information by using the email address and termed as the creeper. This can help in ensuring the authenticity of the devices. Now, digital forensics can be used to investigating the supply chain of IoTs also. By analyzing the logs and metadata of IoT devices, digital forensics experts can identify suspicious activities and events also. And finally, we can help in recovering the data also from any compromised IoT devices. But in this particular study, we are not focusing upon the data extraction and gathering. We are just focusing on the data security that can be provided to the digital forensic investigation during digital forensic investigation, to the various network and IoT devices that are attached in that particular model and in particular investigation. So any kind of alteration or tamperment cannot be done on that particular devices, so they can be used in the court of law. So by moving forward towards the what technology we are implementing here in the digital forensics, that is the blockchain. So if we'll talk about blockchain, it is basically as a digital ledger of transaction that is distributed across the entire network. Now, blockchain basically uses a hash algorithm to to tally the data authenticity. Now, if we'll talk about hashing also, it's just a way to convert the particular or legit file into the unmeaning data. But that unmeaning data and that unique data is the unique for particular each and every data file available in the whole system. So each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to the participant's ledger. So here we are just seeing the very overview and a very scientific way of the blockchain. But if we'll talk in a very simpler way, it is just gathering the data and provide us a very unique key that we will known as in the form of the hash value. Now, hash, if we'll talk about history, it is started with the SHA MD5. It will started with the MD5, that is the message digest 5, and after that the SHA, that is the secure hashing algorithm came. But currently we are using the SHA 256 version, which is providing a very unique, at least 64 character of the identifier codes, which you can or we can easily calculate it from our window PowerShell also by using that get file hash commands. So blockchain is basically, if you talk in a normal term, is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. So this is the way how blockchain is transforming the world, and this is how it was started. But if we'll talk about the scenario of blockchain, how we can using it to make the a particular model in the forensic investigation, digital forensic investigation, that is the talk for our further video. So let's talk more about blockchain. Blockchain, as we discussed, is the distributed ledger technology that records the transaction across a network of computers. Each block in the chain contains the number of transactions, and each block is linked to the previous block through the cryptographic hash, as we discussed, like the MD5, MD1, MD2, or SHA-256, 2125, anything. So one of the key features of blockchain is its immutability, meaning that once a block is added to the chain, it cannot be altered. And if anyone try to alter that particular data or it particular data which is attached in that particular block, whole hash value and hash algorithm, or we can say the cryptography hash of that particular file will be changed. So we will get to know that if any alteration is happened, if we'll just provide a simple dot also in that particular file, whole cryptographic hash will be changed, and by that we can know that particular ledger and particular block was altered by a particular person. So in a dispersed network of uninterested peers, the blockchain serves as an immutable ledger for recording the transaction. The forensics examiners can also use blockchain analysis tools to trace the flow of digital assets, track the movement of funds, and identify the parties involved in the transaction. It can be used to verify also the authenticity of digital evidences that we will gonna discuss in particular in this our video. For example, the hash values can be stored on the blockchain, providing a tamper-proof record of integrity of evidences. Blockchain is the distributed ledger technology, which basically records the transaction. So by getting this particular overview of blockchain, let's move towards the what is our research view. So this paper begins by we outlining how we need the digital forensic solutions for the problems that are associated with the IoT devices. Okay, we have certain guidelines also, process also, but still we are facing so many issues and problems that are put a question over the authenticity of the IoT devices. So the proposed model which we are discussing here will include the use of smart contracts to automate the process of evidences, collection and chain of custody, as well as decentralized storage solution for preserving the integrity of the collected evidences. Okay, so here come our the particular model which is we can or use in the digital forensic investigation, that is the BBMFI, stand for the blockchain based forensic model for the Internet of Things. So this particular model basically contains the four entities, that is the cloud service providers, blockchain centers, user centers, and the log processing center. Now further we will discuss more on this particular things, like how they are associated with the blockchain network. So if we talk about these entities, the first entity that we are occurring is the cloud service providers. So cloud service providers rely on the particular network system and IoT devices for evidences. When it comes to IoT forensics, in contrast to the traditional digital forensics, the dependence on this cloud providers might result in unreliable evidences. Okay, so we suggest an approach using a decentralized ledger, which uses this cloud service providers to ensure the log integrity while also allowing several forensic process parties to examine the logs. Okay, after that, second entity we will about to discuss in this particular BBMFI model is the blockchain center entity. So it is basically a distributed ledger technology that is used to record the transaction across a network of computers. In a blockchain model, each block on the chain contains a group of transactions. And once a block is added to the chain, the information in that particular block cannot be altered. So this allows a secure and transparent way to store and share the information. So the distributed nature of the blockchain means that no single entity controls the data, making it more resistant towards the tampering and fraud. So before being written onto a one block on the distributed ledger, which makes up our this particular second blockchain based entity, each log is processed, and the distributed ledger consists of all the blocks that have been committed to the network. Now, each block contains a transaction value of the hash value derived from the previous logs. Now, these logs are collected from the various entities, hashed and added to the blockchain network as a transaction. Okay. After that, the log processing or center entity will came. It is the center in a blockchain model refers to the network of nodes, so that are responsible for processing and validating the transaction. So this particular log processing entity is responsible for the processing and validation of transaction before they are added to the blockchain. After this, the user center entity, basically it is composed of the courts and forensic investigator. How a forensic investigator have to tally the data which is associated with the blockchain based network in the digital forensic investigation, and how court will believe that particular data is authentic or not. So that is the part of this user center entity. Now, due to the existence of this particular component in the model, forensic investigator may validate the accuracy of logs that service providers send to them, like they are authentic or not. Furthermore, forensic investigator may still verify the veracity of the logs also, even when they are being passed along from one investigator to another. Because while transferring the in particular digital forensic investigation, while transporting or transferring the data from one particular investigator to another one, there is a very high chance of the alteration of data. So the court also has the power to evaluate whether a particular piece of evidence need to be accepted because of its transportation or not. So here court also, by using this particular entity, can check the validity of logs. Okay, so let's have a look towards the framework of the BBMFI model. So here we can see we have a cloud-based network which are connected with the millions and trillions of IoT devices in the network devices. And this particular network devices are connected with the particular Internet of it. These particular devices are connected with the ISPs, which are the internet service providers. So here we can see the IoT devices are connected with the network devices, and those network devices are again connected with the cloud devices. So, and these are the interchangeable features. Now, all the data can be shareable as in interchangeable format from the cloud to the network devices and from network devices to the IoT devices. Same goes for in this particular end also, we are transmitting the data from IoT devices to the network, and from here it was going towards the cloud. Now, this particular cloud here is have the feature to attach the court and forensic investigator, which is using our fourth entity. Now, all the data, first of all, what we did, all the data which is communicated throughout this whole model first have to be gone through the log processor. Now, log processor entity basically altering and getting the hash values of each and every data that is transmitting all over them, and these all things will be connected in the center part of the blockchain. Now, as we discussed about that, the blockchain, so in blockchain model, if we'll talk about in this particular center part of the blockchain, as we discussed, it's a distributed ledger. So this allow a secure and transparent way to store and share the information throughout this whole model. Each and every data which is transferring from the devices to the network and to the clouds will have to go through this particular blockchain based network. So each and every ledger can record each and every data, and they can get their cryptographic hash values which is stored on this particular central part. So this allow for a secure and transparent way to store and share the information. Now, blockchain is maintained by a network of nodes, each of which has a copy of entire ledger. Now, the nodes work together. We can see in these particular edges which are connected from the IoT devices to the central part. These nodes work together to validate into the new transaction and add them to the chain. Each and every time the data is transferring from the devices to the network from the cloud, they were just adding a particular hash algorithm and cryptographic hash of each and every file to the chain, which ensuring that the ledger is accurate and up to date. So the distributed nature of blockchain means that no single, as we discussed, no single entity controls the data. Here, making it more resistant to tampering and fraud. Each and every entity that is here we connected basically for securing the IoT devices, they are not controlling the data. They all have their different meaning. They all have their, different results, and they cannot alter each other interoperability also. So the distributed ledger consists of all the blocks and have been committed to the networks. Each block contain a transaction value of hash value derived from the logs. And this all is the part of the central blockchain. So after this particular network, we can see that the log processor is combining up the blockchain network. It basically surrounded the blockchain network. Each and every data which is shared from the cloud or IoT devices or network devices, court or forensic investigator, have to be gone up with the log processor. And this particular data, as we can see from here to here, if it will go to the court or it will go to the forensic investigator, will be in the authentic form. And in any other node, if any of the data was tampered, then the blockchain have the knowledge of that particular data, and it will report to the either forensic investigator or the court of law. So if we'll talk about how the court can believe and what is the endorsement process, that particular data is authentic or not. So whatever data is coming from the IoT network, they basically generate the logs. Now these logs are, again, as we discussed in the previous one, connected from the blockchain based network. So they have a hashed log. Now if a hash log came to this particular existence, if they didn't match up, then the particular evidence will be rejected. Now, if they match up, it will be accepted by investigator. Also, this all acceptance and hash value is again connected with the blockchain network. Because of that only, they were getting the unique identifying codes, or we can say the cryptographic hash values. So after that, the investigator accepts the particular data and it will be presented to the court of law. Again, while it was presenting to the court of law, the hash log of the previous one will be getting tallied. If the same log will be tallied up and we get the same result and cryptographic value, then it have to be accepted by court. Otherwise, it will be taken as a reject log. So because of this particular BBMFI model, as we discussed, all the particular network devices and IoTs will be connected from the different 4 entities, which have to be gone through the log processors, and in central part, they all are connected towards the blockchain network. So our proposed approach is based upon the blockchain, making it totally decentralized in the contrast to centralized manner, which is described in many previous works. Because of our architecture is decentralized, it is feasible to audit the logs to see if they are authentic or not. It also prevents the analysts and service providers from the surreptitiously altering the logs. Okay. Also, our approach makes use of blockchain immutability property to ensure they are the accurate in their terms and they can be accepted in the IoT environment. Also, it had the benefit of being verifiable. This offers the forensic organization to confirm the veracity and authenticity of the IoT devices that is either not present or is not critically examined in the previous related work. So this particular model need to be integrated in many digital forensic labs or in cyber criminal related organization. So they have a particular and a very precise framework to control the alteration and tamper-proofment of the IoT data or devices, because although it was finally questioning in the court of law, like whether that particular data or particular IoT devices are legit or not, are there any kind of tamperment or alteration is there. So this model basically here derives and allow the particular court of law to believe that this particular data and all the network and devices attached in this particular framework are all legit and provide non-tamperable results. Okay, moving to the conclusion part. So the IoT has brought, we discussed so many proliferation of connected devices in our home, workplace, and cities. We are connected with more than hundreds of IoT devices in our this particular modern world. This device, which includes everything from starting with our smartphones, smart home devices, to the industrial control system and medical equipments, they generate a vast amount of data. And because of this vast amount of data, they can be used for the forensic investigations also. Now, because of the IoT devices also, criminal nowadays started to perform a crime by using these IoT devices. They are often vulnerable to tamperings also, because in digital forensic investigation, the device and the particular data have to be in the non-tampered form. Okay, this makes it difficult for a forensic investigator to use the data as evidence in criminal and civil proceedings. Now, blockchain-based technology, which we derived in this particular work with its decentralized and tamper-proof nature, can be used to ensure the integrity and the immutability of the digital evidences from IoT devices. Now, it implementing an endorsement of the 4 basic logs that we have discussed. which is the blockchain-centered, user-centered, log entities, and a workflow of a BBMFI of the IoT devices in the digital investigation. They all have the potential to revolutionize the way of incident response and better reliability of IoT devices. So it basically ensures the integrity and the immutability of digital evidences, making it a valuable tool for the both forensic investigator also and organizations also which are handling such type of cases. However, it is not important to note that the further research and the development is needed to fully realize this potential of this particular model also, because this particular model is only connected with the forensic lab settings, but we don't know how it can be altered or it can be modified while if we use it for any bigger organization who is more focused on a particular single IoT devices. So if a particular organization is based upon a single IoT devices, then this particular model can be modified also, and it can also overcome any technical challenges that may arise due to the BBMFI. Okay, that's from my end, and thank you so much for your patience and hearing me. Thank you again. Thank you so much.